this is our 12th video in critical path analysis, NS3. And in this video, we are looking at cuts. So a cut is an imaginary line. It's normally a dotted line that crosses a network graph, and it must completely separate the source and the sink. That is very important. It has to completely separate the source and the sink. When you're calculating a cut capacity, it is just the sum of all the edges that the cut passes through. So if this was an edge, this was an edge, and this was an edge, and my network graph kind of looked a little bit like this, for example, and my cut, which is a dotted line, was in red, the cut capacity would be this capacity edge, this capacity edge, and this capacity edge. So I just put in 3 random values, which are representing the capacity of that edge. So the cut capacity would be 8 plus 7 plus 6. You have to take into account the direction of the flow. If this line here, the 8 was passing from the source to the sink, we would count it. If, however, the 7 was passing from the sink, which is here, to the source, you would not count it because it is not separating the source and the sink. It's separating the sink and the source. So we only count edges that are going in this direction towards the sink. So the cut is still valid, however, that edge is not because it is not from the source to the sink. So let's have a look at some examples on the next slide. So as we can see here, the cut is a dotted line, and the cut separates the sink, which is the the source, which is the S, and the sink, which is the A, completely. There is nothing coming from the source that can get to the sink, because if you pictured the dotted line as a barrier, nothing can get through. So that is a valid cut. Let's have a look at the next slide. So here is showing us what a cut is and what a cut is not. So here, as you can see, any material coming from the source gets blocked by the cut. And so there is no way that any material could get through to the sink. And all the edges that the cut is passing through is going this direction towards the sink. If you have a look here, however, all the lines the cut passes through is heading this direction towards the sink. However, not all the material is blocked. For if I went along this edge up here, no cut passes through it, and so I can make it towards the sink. So that is not a valid cut because a cut has to completely separate the source and the sink. So that is probably the most important information when drawing a cut. You need to completely separate the source and the sink. So as we can see, this is a valid cut because it does completely separate all the material from the source heading towards the sink. However, only 2 lines of the 3 are considered valid. So the cut is valid, but the lines in the cut may not be valid. This line is valid because its arrow is going towards the sink. this line here is also valid because its arrow or its direction is going towards the sink, However, the line in green is not valid because it is going towards the source. So it's going the opposite direction that we want to go. And so if I had to calculate the cut capacity for this line, for this cut, I would only count this edge and this edge. You would not count this middle edge here. So let's have a look at this example here. We have to calculate the cut capacity. So if we have a look here, there are 4 cuts, and we will do the first cut first. So this one flows, this line here, flows from the source to the sink, and it does separate the source and the sink completely. So we would do 20 for the first line, which is cut 1. You would do 20 plus 35, and that would equal 55. For cut 2, we'd have a look, and you can see that this line here, worth 20, flows from the source to the sink. This line here, worth 14, flows from the source towards the sink. However, this line here, FB, worth 6, does not flow from the source to the sink. It's flowing up. And so we will not count it in our cut 2. So our cut 2 will just be S to F, which is 20, plus BC, which is 14. So that cut would have a total of 34 because we are not counting BF. Now if we have a look at cut 3, all our lines go directly from the source to the sink. As you can see, they are all going in that direction. And so for our cut 3, we can add C3 equals 20 plus 15 plus 14, and that would equal 49. So our cut 3 is a valid cut, same as cut 1 and cut 2. However, in cut 2, we did not include FB because it was not flowing from the source to the sink. Now let's have a look at cut 4. Cut 4 is a valid cut. However, the same as cut 2, DC worth 12 is not flowing from the source to the sink. It is flowing more from the sink to the source. And so we are not going to count it, and instead we're just going to count FD 20 and CT 10. So the capacity of cut 4 would be 20 plus 10, which is 30. So C4 equals 20 plus 10, which equals 30. So that would be the capacity of our 4 cuts. You only include the edges that are on a valid cut that are flowing from the source to the sink.